All right, we have a lot of questions to get done. So let's see how we can go through them, and then I'll give you to try. Right. Um, let's quickly finish on polymerization. And then we do the questions. We do a lot of questions. Then I can give you on that. And I'll see if I can do isomerism with you guys. Yep. What happened? I didn't. Wow. Why didn't you call me LGK? Definitely. Let me just. Okay, let's get to work. I can't see where I've put those notes from yesterday. Let's continue. I'll send them to you guys when I find them. Right. Let's continue with what we were talking about polymers when we were talking about polymers. I'll just remind you, and then get to the last parts, and then we do a lot of questions. I want to focus more on questions today, so I kind of know you have an idea of what we talked about, so I will not repeat myself too much. Okay? Are we together? We got to the fourth part, I think, when we are talking about deducing the monomer. So let me explain to people. I'm not going to rewrite the notes. I'm just going to share them with you. But let me explain to people what I had talked about yesterday, real quick, and then we can quickly get to the stuff for today. Are you ready? Yesterday I said that polymerization. Okay, for you to understand polymerization, this is a fact. Polymerization, this topic, has 8 parts. Okay? 1, definition of monomer and polymer. 2, addition polymerization. 3, how to draw repeat units. Are you seeing the parts that you must know? How to draw repeat units, which we talked about yesterday. 4, how to find a monomer. We didn't do this. From a polymer. LGK, can you see this? 5, condensation, polymerization. 6, nylon, polyesters, PET, proteins, plastics, and environmental problems. Right. Are you seeing? Right. Let me make sure you know the hard things. Addition polymerization, we talked about it yesterday. We said it's from alkenes. The repeat unit, we said you remove the double bond, right? Make sure, I gave you the parts. Here we want to talk more about monomer, condensation polymerization, nylon and polyester, and plastics, and then recycling, and we'd be done. So I'm going to be moving a little bit fast. Are you ready for that? Can I start? These are the parts that we need to do, then we get to questions. Are you ready to learn? Is your mind ready? Is your mind rested? Are you ready? Seth? Seth, can you hear me? Remember, let me start from the repeat units and go down. Let's start with it. Can everybody hear me? Mazita, can you hear me? Okay, good. Tapelo, can you hear me? Okay, good. That's good. I was just making sure you can all hear me. I'll check the register at the end. Let's get to work. So here we said I needed you to know I need to do right. Let's quickly do it. I'm starting from 3, moving as fast as I can, and we'll be done. Concentrate, guys. I'm just going to remind you, okay, about a repeat unit. We said a repeat unit is the small section of a polymer that repeats many times. And I showed you how to construct it. I said to draw it, you draw it from a monomer, okay? Because we're going to do questions on that. So that's why I want to repeat it real quick, and then we do the questions we got to do. We have to do questions. So everybody, let's go. To draw a repeat unit, I said, and everybody, to draw a repeat unit from right. Let's go. To here, one, change the carbon to carbon double bond. Into a single bond. Then two, add continuation bonds. On both sides, okay? I should say on both sides. Then three, what you must also do is to place brackets. Okay? Then, around the structure, and then the last thing you should do is place an N. So I can say it in any way. Add a small N outside the brackets. And here is one. We said you have ethene, which can be written like this. Let me teach you another way you can find it. Okay? This is the same as doing it like this, students. Carbon, then you put H. You should understand how this works. Then you have your double bond with carbon, then the hydrogens are like this. This, when you make it into a polymer, you won't have to draw the whole thing. You have to just show the repeat unit. They'll ask you about it. Remember, single bond here. So carbon to carbon is now a single bond. Then put continuation bonds outside. Then these bonds here, these two hydrogen bonds, will now be up and down like this. Will now be up and down like this. Let's go. This is how you do it. You put an N. This is a repeat unit. If we were to do it like this, right. This is called ethene, and the polymer it forms here from the repeat unit is polyethene. So when you read a repeat unit, it's like it's the polymer itself, only that it's a section of the polymer, but it's the very same thing. So please, the repeat unit will be the polymer itself. Okay? Now let's do the fourth thing, and let's finish it. Deducing the monomer, okay, from the polymer. Deducing the monomer from the polymer. Deducing the monomer from the polymer. Write this down, please. Then, here are the steps. To deduce a monomer from an addition polymer to deduce a monomer from an addition polymer. Number one, first identify the repeat unit. So you get a polymer. If you're asked to show the monomer, find what's repeating. Find the small section of the polymer that keeps repeating. That's the repeat unit. Find it. Then when you find it, you write it down. Then you remove the continuation bonds. Remove the continuation bonds. Then 3, change the single bond between the carbons or the carbon atoms into a double bond. LGK, can you see this? Can you see this? You get a polymer. You get a polymer. Whatever, if it keeps going. Let's just say you now get the repeat unit. Okay? If you now have the repeat unit, then now that you have the repeat unit, you see the big chain, you find the repeat unit. Once you have it, you change this single bond into a double bond, so it will be like this. Then you remove the continuation bonds and you remove N. Remove the continuation bonds, maybe let me say, and N. And small n. Are we together? Are we together? So this will be the alkene monomer. Okay? Don't remove side groups. Don't change positions of atoms. Don't leave these bonds being single. It's a common mistake. Make sure you change it back to a double bond. Listen, you have to hear it because it's a common mistake. Make sure this single bond that was in the repeat unit. Hey, the biggest problem I know from students is that they want to change from repeat unit in the polymer to a monomer without putting the double bond back. The monomer has a double bond. The repeat unit does not, but the monomer does. So when you change back, please, I beg you, put back the double bond. And this N, you're going to put it here at the back in front to say N molecules of this. I'm sure you know about it already. Hopefully, I've made you know. Are we together? Please remember to bring back the double bond. I'm begging. I don't want to see wrong things. 5. Let's talk about condensation polymerization. I don't have time. Let me move. Yes, are we together? Right, let's go. Condensation, polymerization occurs when monomers join together. Condensation polymerization occurs when monomers join together. And it's the same thing as addition, basically. But here is the last. With the removal, that's the only difference. Listen, with the removal of a small molecule. That's how it happens. There's the removal of a small molecule. And this is water, okay? Usually water. Almost all the time. For us, it's always water, so we don't worry about it. So basically, we no longer have a double bond. In alkenes, we had the double bond splitting up. In here, they make space for the things to join by removing guys. So it's a very unfair way of making polymers. Very, very unfair. Are we together? Hello? Okay. The monomers contain the following functional groups. I'm helping you to see the monomers that we are going to do here. It's going to be 1, carboxylic acids, 2, amines, and 3, alcohols. Okay? And we're going to have them do condensation polymerization. And when they do condensation polymerization, we get a water molecule as our byproduct. What is going to be removed is a water molecule. Okay? So let's do it. Examples to know. Let's put the examples to know. Nylon, PT, proteins. Are we together? Hello? Are we together? Right. Now let's start with nylon. That is the number 6. Let's talk about nylon, which is part of condensation polymerization, and let's see what we can know from it. Nylon, and say this is a polyamide. We start with nylon, which is a polyamide. Okay, so nylon is a polyamide, and I'm going to make you know what it is, what that means, but just right here to say made from 1, dicarboxylic acid, and 2, diamine. What happened there? Honestly, sorry for that. I want to show you the diagram real quick. Let me share my screen again. Let me share my screen again real quick. We have work to finish here. We're starting with nylon, and we do questions. Come on, let's move. Nylon is a polyamide. So let me explain to you, because you're going to meet this, those who continue with sciences. You're going to meet something which you call an amide. Right. So when we say it is made from a dicarboxylic acid, let me write it like this. Dicarboxylic acid contains 2 carboxylic acid groups. Okay? It contains 2 carboxylic acid. Dicarboxylic acid just means it's a carboxylic acid on both sides. Okay? A diamine contains 2 amine groups. Let me explain. Right. So nylon is going to have something like this. There's going to be nitrogen. There's going to be carbon bonded to double bond, or like this. This is what we call an amide linkage. Are we together? Students, are we together? What they call an amine is nitrogen bonded to carbon, but this nitrogen is not bonded to a carbon with oxygens. It's bonded to carbons that have hydrogens or something. This is an amine. Are we together? This is an example of an amine. It cannot be bonded to a carbon that has oxygens. So there are two situations that you meet. Are you listening to me? Students, there are two situations you meet. One is you have your nitrogen bonded to only a carbon with hydrogens. That's where it starts. That's an amine. That's a simple situation. Then when we get to a crazy situation, which doesn't always happen, what we call an amide, which will only happen when we are forming nylon, it is when the nitrogen is bonded to a carbon with oxygens. Are we together? So we should quickly draw that. Are we together? So we say it like this. Let's form the amide so that people can see. Carbon double bond with oxygen. So the nitrogen is right next to a carbon which has oxygen? Yes. So if the nitrogen is connected to a carbon with oxygen, with a double bond and oxygen, that's an amide? Yes. That's always an amide? Yes. And that's an easy way to see nylon? Yes. The amide will be repeated? Yes. So you form, let's just make two things. You're going to have C2H4. I don't care what we have here, but this side we have your carboxylic acid, okay, which is COO. If you want, you can say COOH. Okay, I don't have a problem with that. Then this other side you still have the same thing, your COOH. Okay, so it is, you do it. So C2H4. Look. Like this. Are you seeing this? So they come together, students. We don't care what happens. But when nylon is being formed, we have something with a this is a carboxylic acid, C double bond OH, and it has it again on the other side. What? Sir, what is that? This is a dicarboxylic acid. And when you name it, you look at this. How many carbons does it have in total? 1, then these are 2, it makes them 3, then this is 4. So you say butane, then you say dioic, then you say acid, because it's a dicarboxylic acid. 2 acids. Then we have a diamine, which we say you need to tell us what are the positions. Tell us what are the positions of the nitrogens. One nitrogen is on the very first carbon. The other one is on the second carbon, because there are 2 carbons here. So it is, how many carbons do we have first? 2. So it is ethane. Then how many nitrogens do we have? 2. What are their positions? Because it's a diamine. It'll be on position. If there were 3 carbons here, then it would be on position 1 and 3. Or what? Here it is ethane 1, 2. Then you say diamine. Okay. condensation, polymerization. Right. Are you seeing? Are you seeing this, students? Students, are you seeing? Hello? Right. This is what it would be like. These two. And you just form. Now, let me say something right away, which you're going to need to know. This dicarboxylic acid is going to keep coming. This dicarboxylic acid is going to come for the second thing, which is called PET. So you have to know PET and you have to know nylon. Right. When we say PET, it's a shortcut. Okay, there's a bigger name, I'll tell you. But the dicarboxylic acid is there for both of them. And here it is meeting a diamine. On the other side, it will be meeting a diol. Because I told you that the only thing you expect to meet is some things with carboxylic acids on both sides, amines on both sides, and alcohols on both sides. This guy will be there in both. This guy will be there in nylon only. He will be there in PET only. What you must know is that we need to make space to make these things start to join together. So he's going to sacrifice OH. This one will sacrifice H. And also this one. And also this one. Because they have to sacrifice on both sides to join from both sides and make a continuous chain. At the end of the day, you're going to have this OH. So the carboxylic acid always sacrifices an OH, sir? Yes. Then the other guys, whether it's the diamine or the diol, which means the two alcohols, they always sacrifice just an H? Yes. Okay, so in terms of sacrificing and what I'm going to get, I understand that now, sir. Thank you so much. Okay, you understand it? Yes. Thank you. Now, I need to know how to then draw the polymer. Now, remember, when you're doing the polymer, all you need to put is the repeat unit. You need to put the repeat unit. So we're going to need to see, you put an N, we need to see it. That is why I repeated myself on repeat units. What you're going to do, what am I going to do? You take this thing, let's just put it, the carbon, this carbon is there, right? With its double bond O. Then you do it like this. Here it is. Now we have gotten open here, open here. Okay? This bond is now open. And here it's now open. We've made space, we've removed. These two will join and go and form a water. So will this one and this one. Then what remains is this nitrogen coming to join in. And this nitrogen has this hydrogen, so it has that hydrogen and its own C2H4 or whatever, and nitrogen and the hydrogen. There we go. So this is the polymer. This is the repeat unit, which will keep repeating, I don't know, whatever, how many times. And you can put your water molecule. Okay, even two of them get released. This here is why this we say is a polymer made of amide bonds. A carbon with a double bond will at some point meet a nitrogen with its hydrogen. That's an amide. This is the amide link. You're going to meet it. You are going to study amides at A level and at university. You study amides deeper. This is an amide link. Anyway, let's move on. Now, the second thing that people should know is how to then use boxes, okay? How to use boxes. So when you're using boxes to represent, you just say, okay, let's say I have this. It is this, okay? Can you see it? Then this one will be represented by a shaded box. If you want a shaded box to represent the guy that was inside your dicarboxylic acid, don't let me down. The guy that was inside your dicarboxylic acid is this one. We don't want to know what he is. If he has 10 carbons and 50, whatever hydrogens, we don't care. Okay? 10 carbons, 20 hydrogens, we don't care. 11 carbons, 22 hydrogens, we don't care. What we know is he's there, which we don't care about, but we know that on one end and on the other end, he has carboxylic acid. So we put those. He has carboxylic acids. Then what we know is the person he's joining to has amine and amine on both sides. So there's another box which happens not to be shaded this time to show it's for the other guy. He will have, students, you show him, he will have nitrogen both sides. And it's like this, it joins. If you've made your carbons face up there, you make your hydrogens face down there, something like this. This is what happens. And we know what it's bonded to. This guy, shade him. Oops. Wait. It's bonded to this guy as well. What does he have? Carbon double bond O. What does he do? He joins in with the nitrogen. And this continues to happen. Did you see that? Simple fixture, right? You can keep putting, I don't care. If you keep putting, then you can put another one. This chain keeps going. We know that. Have you seen that? What is this? Nylon. Are we together? Okay. The polymer using boxes. This is the diagram. Should we go to polyesters? The second thing now. Are you done with nylon? Hello? Yes? Why is this in a polyamide? Because if you look at it, it has these many amide linkages. Carbon double bond O with the nitrogen, blah, 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 blah. And then now we go to the next thing, okay? Now we go to the next thing, and we are now on PET. Are you ready? Let me write nicely. Write 7. Write polyesters and PET. Polyester and PET. Are you there? PET is a polyester. What did we say? A polyamide means many amides, many amide linkages in the bond. Polyester, many ester linkages. We know what an ester is: carboxylic acid and alcohol. PET is a polyester formed by condensation, polymerization. I need to finish this. Come on. Condensation, polymerization. I'm almost done. One more thing, yeah? Condensation, polymerization. Just a few more things. Okay. It is made from one, a dicarboxylic acid, two, a diol. Are we together? PET is used, before I show you, in plastic bottles and synthetic fibers. Such as Ch.11. Okay? Students? So this is, in brackets, trade name for PET. So nylon and terylene. PET in full is actually, in short, is terylene when it's in trade, but this is polyethylene terephthalate. Did I do it well? Terephthalate. Yeah. Did I do it correct? Terephthalate. Whatever, if it's wrong, it's okay. But it's close. Anyway, terylene is the other thing. So when you're asked for the two condensation polymers, you might as well say nylon and terylene. It's still fine. We used to call, that is when I wrote my IGCSE, we used to just say nylon and terylene. Let's do the guy. Dicarboxylic acid again. Don't let me down. Do not let me down. Where's the problem? Tell me, where is the problem? In knowing that you start with something that is a carboxylic acid, don't you know this is a carboxylic acid when it has this? When something ends with this, don't you know it's a carboxylic acid? Now, are you seeing that it's carboxylic acid on both sides? Can't you see that? So can't you see this is a dicarboxylic acid? Right. We can even change this to put 4 and 8. Or say 6 and 4, rather. This should be like, they call this terephthalic acid. Even if you keep it as C2H4, I don't mind, to be honest. Then, what happens? It ends with an OH. It meets this guy, C2H4, ends with OH here, ends with OH here. What is this? We call it a diol. So this is ethane, okay, because it has 2 carbons. So it's ethane, then you say 1, 2, dash 2 numbers, 1, 2. Then when you're going back to letters, you put a dash, then you say diol. Here you can say this is butane, dioic acid. Then you quickly do, we know what happens. This guy always sacrifices his OH. If it's the acid, this is an H. Then this OH also goes. So does this H go, right? And now we can start to form these polymers. We just put the repeat unit. So let's do the condensation polymerization. And let's put the repeat unit. Condensation polymerization. Let's put the repeat units. That's the only thing we gotta put. Then we get to proteins. We just put this guy. And here's a double bond O. Okay, carbon with a double bond O. This one. And it's open now. There we go. O. There. Like that. Then we put H2O. Have you seen? Right. This right here ester link. This is a repeat unit of a polyester. Now let's put how you represent this. You now know how to do it. Let me quickly do it with you. Put the first box. You can shade it or you may not shade it. I don't care. You know that this one is a double bond O and a double bond O. And it is open like that. Now the other box we put, the second box which we'll put, we won't shade it. And we know that instead of a double bond O and N, it's just an O, which will now bond and continue. Wow. Really? Yes. Then the next one, okay, the next one, shaded, connected to a C double bond O, which then connects. Then this C double bond O, which connects. Then the next one would be empty, which is connected to NO, which connects, which is connected to NO, which goes. So you must know what your boxes have. Just like the other one, we know it had one had C double bond O, this one, the other one had an N and an H. And we knew it's like that. This is what you'll be having. And that's how you use boxes to draw the structure. Okay? Using boxes to represent the chains, the carbons. Are we together so far? Hello? Are we together? Students? Right. Now, should we start with plastics? Or should we start with proteins? Can you tell me? Let me do it like this. Let me do proteins. Let's talk about proteins. We are done, guys. We are done. You've done the hard part. Okay? Write with me to say proteins are condensation polymers. We'll do some questions. made from amino acid monomers. Amino acids contain one, an NH2 group, two, a COOH group. So make sure, just note this very same thing we did with our polyamide. We have an amine and we have a carboxylic acid. Are you seeing? Now, so basically, we can say that proteins are polyamides. Just like nylon? Yes. Okay? Only that they are natural polyamides. Are we together? Okay? They are natural polyamides. You can say here. Why? They contain many amide links. Okay? And occur in living organisms. Are we together, students? Hello? We'll be calling them peptide links, and that is how we form a protein. Are we together? Right. Write with me to say here. An amino acid contains an NH2 group on one side and a COOH group on the other side. Okay? So let's show one. Going to let me put nitrogen here. There we go. Have you seen it? Have you seen it? Students, are you seeing now the protein? Are you seeing now the amino acid which then forms the protein? You've seen the one which forms the nylon, you've seen the ones which form the PET or pterylene. Now you are seeing how we form a protein. We have, this is an amino acid. Amino for amine, acid because it has the acid. So it is both at the same time. That is why we call it amino acid. So amino acid, what changes on you for us to get different proteins? It's this part. But we know what he has at the end. he has a carboxylic acid on one end and an amine on the other end. Have you heard me? They come together now. Have you seen? Then right. Let's see. Let's see here. Sorry. There we go. Let's finish it up. This is the last one. Come on. Come on. Condensation, polymerization. We are here. Obviously, you know what you get now. You can all see what you get. What will you get? The same thing. You put this thing, then you put this, joining to him. So we do that. So you have your nitrogen, like that, with two hydrogens, bonded to a carbon like this. Okay? You don't put it like this now. You put it like this. Then it connects, okay? It connects with this nitrogen who has made space by selling out one of his friends. And it's now the nitrogen like that. There we go. Peptide link. Are you seeing this? Now let's make it. Let's put it. This is now an interesting one because guess what? When you do the boxes, we actually don't care the order you do. But now you don't put the same thing both sides. This side, we have a nitrogen. Okay, I made a mistake here. This should be like this. Wait. This is not a repeat unit, and it begs for problems. You can put it like that, I mean, if you are making only one, your protein just like this. But if it keeps repeating, then you'd have to put this continuing. If I, for example, now do the boxes, I need the nitrogen on one side, of course, which is a hydrogen and is open, definitely open. And on the other side, I will need a carbon with a double bond O here. Okay, I don't care about this. It's here. I care about the tips, the ends. That's what you'll be doing with the box. Now, basically, you join him to this thing again. So, but now the nitrogen should face down and the box should be blank, and the carbon double bond O should face down as well. Then you get to the next one. He is bonded to what? To a box. And what is the end of that box? He just don't go to a box. That box should have an end because he's an end. The box should have an end. It is a nitrogen with a hydrogen. Now you put the hydrogen up, which is on the box, and ends like this. Right. Now you put a nitrogen going down. That box is now empty, which is like this. Are you seeing? Are you seeing? Now we'll go to plastics, because I believe you're done. I believe you can do the boxes with me. Because you know everything comes from the ends of those boxes. In PET, one box has C double bond O on both sides. The other one has O on both sides. In nylon, one box has nitrogen with hydrogen on both sides. Then the other one has carbon double bond O on both sides. And they are joining. I don't want to see fiction. You better put the boxes joining with their ends there. For protein, you need to show nitrogen and hydrogen on one side and carbon double bond O on another. Then you join it to the other box. You just don't join it straight to the box, obviously not. You join it to the end of the other box, because the other box also has an end. He also has something at his end, which is now a nitrogen and a carbon double bond O like this, which joins to the end of another box. Be careful. Are we together? Students, don't let me down, students. Don't let me down. Thank you. Now, let's do the next part, okay? I'm going to write in like 9. Thank you for all this, sir. Now let's do plastics and the disposal. Are you seeing? Are you seeing? Are you seeing, everybody? Right. Let's quickly write. Just going to quickly write important parts. Write this. Many plastics are chemically unreactive and non biodegradable. They are not biodegradable. What do you mean when you say they are not biodegradable? Right in bracket. Okay. This means microorganisms microorganisms cannot break them easily. As a result, disposal of plastics, which are polymers, plastics are polymers, causes environmental problems. Microorganisms, bacteria, and all that cannot break down plastics. So their disposal is a big problem. Plastics disposed of in landfill sites take up valuable land. Like we're actually just done, okay? We're doing a bit of theory that you must also know, but the main ideas are done. We've crossed the T's, we've dotted the I's. You're doing very well. Okay? Hello? Are we okay? Let me say why we are studying. If you want to know, just you can write to say plastics are made from polymers. These are just polymers. Okay? Plastics disposed of in land take up valuable land because they do not decompose. Because they do not decompose. Plastic pollution in oceans harms marine life. Plastic pollution in oceans is deadly. I'm telling you, it causes some environmental issues there. It harms marine life. Okay? What about burning them? Incineration or burning of plastics, when you burn them, you're going to release carbon dioxide, which contributes to climate change. Which contributes to climate change. Give me a sec. Give me a second. Right. Okay. Well, yes. Okay. So here are the problems. We say number one, they take up valuable land. Okay, because they do not decompose. Number two, if they're in oceans, it harms marine life. Number three, we said it releases carbon dioxide, which contributes to global warming or climate change. Okay. Uh, Number four, you can say, uh, some plastics, some plastics like PVC. Can you see all these problems? Release toxic gases. Okay? E.g., HCl when burned. Okay? When burned or burnt, I don't care. Whatever. Then, last one, incomplete combustion. Are you seeing all the problems caused by plastic class? Can produce toxic carbon monoxide gas. Are we together? Right. We'll do example questions. We'll do example questions. I don't want to do too many because for the sake of time. Are we together? I'll do example questions. Now let's talk about the very last thing. PET repolymerization. And recycling. Are we together? Write this. Just write this. Not too many. I'm just going to give you 3-4 lines. 4 lines that I'm doing. And we do questions. You're doing very well. I'm proud of you guys. Let me see if I'm still live. Yep. Okay, it's going on well. Wow, why is the network red now? Why is my Starlink red? I don't know why my Starlink is red. The network is weak for some reason, guys. I don't know why, but anyway, it doesn't matter. Let's keep going. Right for me to say PET, which is terylene, is a polyester. Yes. Used in plastic bottles and fibers. PET can be depolymerized it can be depolymerized into its original monomers. Really? Yes. I can take it back? Yes. Okay? Really? Yes. Using enzymes or by using other chemical methods. Really? Yes. The polymers or let's say no, the monomers that are reformed can then be repolymerized. Wow, this is cool. To produce new PET. So that's why bottles can be recycled. Yes. Terylene, yes. Terylene can be recycled. Yes. And they can make new terylene. Yes. Wow. So what do? They depolymerize and they repolymerize. They depolymerize using enzymes and repolymerize into new PET. Wow. This saves resources. This saves resources. And energy. And reduces the carbon footprint of PET production, reduces the amount of carbon dioxide released, basically. I hope you're enjoying. Sorry for this jam. It always comes when I'm enjoying myself. Okay. Right. Let me share my screen. Are we together, students? Hello? Okay. Now, we're done. Let's do questions. Let's do questions. Let's do questions. May, June 2023. First paper. Say questions. Polymer questions. I'm telling you which papers you then go to. Okay? The papers which you then go to and open and you do the questions. So, first one, polymer questions. First one, May, June 2023. Paper 42. Number 6. This is the one we are doing. Question number 6. Let's see here. Are you seeing the questions? Students? We're only looking at the polymer question. Hello? Guys, can you hear me? Right. Give us one repeat unit. How easy is the repeat unit? You take one box. Let's say I take this box, for example, right? If I take this box, then I'm going to end at this one. And we know that it's like this. This box, if he has carbons connected to him, it means the other one has oxygens connected to him. So we move him with his oxygen. So it's going to be like this. This is it. So you can circle it or you can do whatever you want. Okay? This is the repeat units because they say it's circle one. Draw the structure of the monomers which make up PET. Draw the structure of the monomers. Right. If I want to use the box, it's still fine. You can do it like this. Then you say OH, OH. Then you do another one. And you shade it. And you say C double bond O, OH. C double bond O, OH. Okay? Are we together? So easy. State the type of polymerization used in making PET. All these are condensation. So we saw it's condensation, polymerization, and we're done. Is there a question? Students, is there a question here? Hello? Is there anyone with a question here? Let me refresh. Huh? Students, is there anyone with a question? Oh, you're all good? All right, so you see that this one is done. Mazita? Mazita, can you hear me? Okay, great. Let's go to the next one and let's write it down. Let's now go to May, June 2024. This is paper 4-1. So can you write, everybody? May, June 2024. Paper 4-1. Write this. Open this one. May, June 2024. Can you all write it? Write it, write it, write it. I need you to write the link because just writing solutions within a week, you'll be regretting. You'll be wishing you had written the question we did down so you can go back to it. So this is May, June 2024, paper 4-1. Write it down, guys. I know you need it. That is why I'm saying you should write it down. Write down to say May, June 2024, paper 4-1. Now, write question 7. Write question 7. Then we go down and we do polymerization. Right, let's do the polymerization question now. Number 7. Empirical formula, no. Molecular formula, no. Here is a section of a polymer. Ooh, okay. Section of a polymer. Draw the displayed monomer that forms this. Oh. What is the repeat unit here? Repeat unit is this. Okay, I can take it like this. So I need at least 2 carbons. I need at least 2 carbons. So I can't take 1 carbon. I need at least 2 carbons. Then what do I do when I'm doing the monomer? I've said it over and over again. If you ever want to get it correct, remember to put the double bond. Then remove these ones. Then now your double bond is like this. And you can put your carbons. Are we together? Here, it then bonds with, look students, don't let me down. Carbon, double bond to carbon. This is to CH3. This is to CH3. Then here is to H. You can actually put it like this, to CH3 and to H. Here CH3, here to H. Then it says name the monomer. What monomer is this? Okay. Here, name the monomer. Here it's but. You can see, let me help you something, which is so important. When you are going to name something, the first thing you always find is longest chain that you can move through carbons without raising your hand. Here I can start at this carbon, move like this, like this, like this, without raising my hand. So the longest chain is 4 carbons, so it's but. Now, where is the alkene bond? If this is 1, that means it's between 2 and 3. Remember, alcohol and alkenes, you tell us where they are. It's not part of polymerization, but the naming you should just know. I'll teach you naming better when I have to. So here, it's because when you do alkenes and you do alcohols, if you don't tell us where it is, I'll be so disappointed. Because you'd have thrown away marks. So here you'd say, this because it is on position 2 and 3, the double bond, you take 2 as your position. It becomes but because it was going to be butene. It's but because it has 4 carbons. It's in because it's an alkene. Now, because it's on position 2 and 3, you say but, then you say 2, then you say in. You could have said 2 butene, but but 2 in is the better way. Are we together? So here it was, do you know how to come from polymer to monomer? Yes! How? I showed the repeat unit first. Then what do? You change the single bonds to double bonds. And you remove the extension bonds here. Are we together? Students, are we together? Well done. Now let's do this one. Is it the same one? Yeah, this is the same one. October, November 2024. Right. Question 3, polymers. And say October, November 2024. Okay. This is now October, November 2024. And it's paper 41. Paper 41. And say question 6. I love this question. Looks like it's fun. Looks like it's fun. October, November 2024. Everybody? October, November 2024. And we're doing paper 41. And we are doing question 6. Let's quickly go through it and let's see. Did you write it down? Anita, you wrote it down? Anita? LGK? Have you written it down? State the type of condensation. State the type of polymerization reaction where natural polyamides are made from. All these are condensation polymerization. All of them, except for the addition polymerization, guys. So this is condensation polymerization. State the term given to natural polyamides, proteins. There we have an amino acid. Thank you so much for putting an amino acid. Then they said complete fig 6.2 to show the general structure of an amino acid. Okay, you want me to show the general structure of an amino acid? Here you put R. Here you put your double bond OH. Then here you put N. And you put H. And you put H. This is way too easy. They gotta make it harder. We know that there is an R here. If hydrogen is here. If hydrogen is here, then we put R here. So they gotta make it harder. This is way too easy, man. This is way too easy. Now, next question. Next question. It's now saying part D is now saying you have an amino acid and another amino acid and another amino acid, and they say, can you now show us how you would get the protein? This is way too easy. So let's choose, guys. Here, if I put N because they said it's N, so you put your N because there's N this side. Obviously, he's left with one hydrogen. The other one is gone. They sort him out. And this other side, obviously, he's just C double bond O. Right? That's all that's left. This OH will go. So here I remove the OH. Here I remove one N. So I remove like this. Here I remove one N. Here I remove the OH. Here I remove one N. Here I remove the OH. It's kind of like the game. So let's now just join like that. So that means basically I have the CO, which is here. Now I need NH. So if these ones were facing up, the next ones will be facing down. So N, the H is down here. And he joins. And there is C double bond O facing down again, which now joins to N with an H facing up, and they join like this, which now joins to C double bond O facing up, and it's like that. And we are done. Way too easy. Well, not now, chromatography man. Not now. We'll talk about you later. We ain't doing you right now. We'll talk about calculating RF values. But is this easy? You should master the boxes. Are we together? Tobo? Are we together? Well done. Kelly, are we together? Anutito? Right. Now, let's go to the next one. October, November 2024. Paper 42. Number 6. Yes. Have you done it? Right, this October, November 2024 is the next question. Now we are doing paper 42. It is the same number. It's number 6 again. On the other one, it was number 68. It's number 6 again. Let's see if there's any difference anyway. I mean, they're very similar. You can see that the questions are very similar. And we are getting used to them, man. So let's see what they're saying. Part of a polyamide. I don't want to read that. I want to read the question. I'm not going to read this, okay? This is all not going to be read by me. I'm not reading that. I'm reading the question. The question is here. Draw a circle around one amide linkage. One amide linkage, really? Amide linkage is this one. Nitrogen meeting a carbon with a double bond. Oh, that is what we call an amide linkage. Thank you. Show all the atoms and all of the bonds. Okay, what is it? This fig 6.2 shows 2 monomers needed to make the, the monomers. Let's put it. We know that it is a dicarboxylic acid, and here it's a diamine. So you put your amine on both sides. Right? Let's now say, name the other products in this polymerization. So 2 monomers needed to make the polymer. Show all the atoms and all the bonds in the functional groups. We have done it. Now name the other product. Name the other product that is going to be used in here. Ooh. The other product? Formed. Oh, formed. Okay, water. Water. The other product formed is water. It's released as a byproduct. I had missed the word formed. Hey, I was wondering what is going on. State the term given to natural proteins. Natural polyamides, we talked about them. Name the type of monomers which are used to make natural polyamides. Natural polyamides, in other words, proteins. What monomer makes proteins? Amino acids make proteins. What do they want us to do here? They are now saying complete to show of this monomer. One of the monomers which forms part of the protein has 3 carbon atoms. It's like this. Displayed 3 carbon atoms. Okay. 3 carbon atoms. So I'll put a carbon here and a carbon here because they said it has 3. And here it is like this. Because they said it must have 3 carbon atoms. They are trying to catch us. Natural polyamide, they are very, okay, let me give you a tip. Whenever you see the word natural polyamide, please don't even read it. Say protein. They are trying to trick you. They are trying to trick you. Monomer of protein is an amino acid. Here they said it has 3 carbons. You know that there's going to be 1 here, 1 here. So don't put an R because they've told you the number of carbons is total. They said 3, so you put 1 more carbon here. Like that. And then this is what it is. Name the 2 types of monomer molecules needed to make a polyester. Dicarboxylic acid and diol, because this is a polyester. If it was a polyamide, it would be a diamine. So diol. Oh, now draw part of the structure and show 2 repeat units. 2 repeat units. Okay. So in other words, it's going to be 4 boxes because each repeat unit has 2 boxes. So if I start with I don't know, shaded box or unshaded box, doesn't matter. Let's start with a shaded box. What I'm going to have this side, I am going to have, let me put N with an H. Then this side I will put, no, not N with an H. I'll put an O because we are doing the pterylene. So pterylene has diol and dicarboxylic acid. So definitely on the other side it will be C double bond O like this, then bonded to an O, then bonded to another box. Or the other side is also an O rather, because here remember you have a diol, which means he was an alcohol on both sides, and he's meeting another box which is a dicarboxylic acid, which is like this and like this. So this is a dicarboxylic acid and he is joining to a diol, which again happens the same thing. You make another box which is a diol, okay, a diol, which means he has O this side and O this side. He can continue. Then he is going to join to a dicarboxylic acid. Don't change the way we do it, guys. Don't change the way we do it. I almost did and I almost got punished. Here it's like this. Then you can do something like that. So this is what you have. This is going to be 1 repeat unit is this. Then the other one is this one. Are we together? Students, are we together? Is this hard? Is this hard? No, it's not hard. I'll give you, then you should do the solutions, and we'll see how it goes.